on light. I have given you some questions. A student, screen paper, this is we have done ray diagram, we have done draw the diagram from the front here. Okay, do question talking about the question number 1, question number 20. Okay, identify the device used as a spherical mirror lens. We have also discussed this one. An object is placed between device and its focus. Image formed is enlarged and behind it. Image formed is enlarged and behind it. Tell me, let me turn on the camera. Which type of image is it? Is it formed by it? Tell me which type of image is formed by what I'm saying here. Tell me. In question number A, 20th A, the object is placed between device and its focus. Image formed is enlarged and behind it. Tell me. Enlarged and behind it means enlarged and behind it. What does it mean? Behind it. Behind means the virtual image is formed. My voice is clearly audible to you?
Yes, sir. Sir, are you asking if it's virtual or erect?
No, I'm not asking. I'm asking the which type of mirror it is used. Which type of mirror it is.
Concave.
Why concave?
So, if because in a concave mirror, if uh, if an object is placed
Yes. Between focus and
so
pole, then
device.
between yeah. You are right. Okay.
Yes, sir,
So
but
if I'm
like I didn't check the question properly. What is device again?
device is actually lens or mirror. It can be a lens or it can be a mirror. Okay. So it is a mirror. Okay. Which mirror? Concave mirror. Because when an object is placed between pole and focus, it forms a virtual image which is behind and enlarged. So enlarged virtual image is only formed by concave mirror. Okay, because plane mirror forms virtual image, but it forms of same size. Got it? And
Yep.
convex mirror forms virtual image, but it forms diminished. So enlarged virtual image is only formed by concave mirror. Okay. So today we're going to discuss the numerical problem related to the spherical mirrors. And in the previous class, we have discussed the sign convention. I'm going to explain you one more time. For example, this one is the positive y-axis. This one is the negative positive x-axis. This one is negative x-axis. This one is negative y-axis. Okay. If we have to measure the distance of this one from here to here, so it will be measured in terms of y-axis. So this will be positive. If I have to measure this distance, that is the object distance, that will be positive.
Negative.
Sorry, negative. Okay. If the distance is from here to here, this will be positive. If the distance is from here to here, it will be positive. Okay. From this is again positive. And from downward, if we have to measure the distance this, so this distance will be negative. Have to measure the distance this will be negative. So let's discuss and do some numerical formula. We have the mirror formula that is going to have the value, or we can say that f is equals to 1 by f, where f is the focal length. 1 by f is equals to 1 by v plus 1 by u. 1 upon f is equals to 1 by v plus 1 by u, where f is the focal length, where f is the focal length, v is the image distance, and u is the object distance. Object distance. Moreover, we have two formula. M is equals to minus v by u. This is M is magnification. Magnification. V is the image distance. Image distance. And u is the object distance. In the previous class, I have also discussed that the magnification M will be taken as positive for virtual image and M will be taken as negative for real image. Understood, everybody? Understood? Amar, Abir, Ashish?
Yes, sir. Yes, sir.
Okay, please note it down.
Done, sir.
Okay. Wait a minute. So let's do the numerical related to this topic. Okay. Do question number, please note the question number 36 first and then start doing. Question number 36. We have to start doing question number 36. The size of the image of an object by a mirror of its focal length 20. So here a focal length is given to you. Okay. Centimeter is observed to reduce by 1/3 of its size. It is observed that it is reduced by 1/3 of its size. Okay. At what distance the object be placed from the mirror? Okay. It is asking that what distance the object must be placed, means u is being asked, and what is the nature of the image and the mirror. Can you predict the nature of the image? Without solving, can you predict anywhere in the class? Anybody in the class?
Sir, diminished images form.
Yes, diminished image is found, that is 1/3 of size. And is it virtual or real? Is it given or not given? Tell me.
Not given, sir.
So if you have knowledge, you can predict this one by using the, let me explain you. If you think that here, okay, let me explain you. Let me explain you. So if I'm having this mirror, okay, and it is saying diminish image. So a diminish concave mirror form both enlarge image and virtual image. Okay, virtual image. Okay, it form both. Enlarged image can be only virtual image. Okay, or if I'm talking about it form enlarged as well as diminished, enlarged as well as diminished. Okay, the enlarged image can be virtual and real both, but diminished image can only be real, can only be real. Okay, got it?
Yes, sir.
So if it is forming 1/3 of its size, it means it is forming diminished image. 1/3 of its size means not forming the enlarged image. If we have enlarged image, if it is given 3 times, then we can predict the two cases. One is enlarged, one is real. Okay. One is virtual and one is for real. If it was forming enlarged image. Okay, because enlarged image is formed when the object is placed between pole and focus, sorry, radius and curvature and focus. The enlarged real image is formed, real image, real and enlarged image is formed. But, and second case, if the object is placed, between pole and focus, then the virtual enlarged image is formed. Virtual enlarged image is formed. But here diminished image is formed. So diminished image is formed when the object is placed beyond R. When the object is placed beyond R, then the diminished image is formed between R and F, and it is always real. Okay, got it? So there is no chance of forming the virtual image, because virtual image, virtual image can only be enlarged. It can never be diminished. Got it? Got it? You understood, everybody?
Yes, sir. Yes, sir.
Yes, sir.
Okay.
Sir,
Now
but it
moving
is
to
not mentioned if it is convex mirror or concave mirror.
yeah. Coming to that point also. For example, let's suppose it is convex mirror. Now it can form the diminished image, 1/3 of its size. Okay. And if it is forming diminished image, so it can be virtual, also. And it is not mentioned that it is concave mirror or convex mirror. So let's check the question. And it is being said that the size of an object, the size of image of an object by a mirror having a focal length 20 is observed to reduce 1/3 of its size. At what distance the object is placed from the mirror? Okay. And what is the nature and the mirror image? So considering that if the we can consider two cases. If the virtual image is formed, if the mirror is convex, then we can also consider this one, because there is no hint is being given that the object is placed in front of the mirror. Is it written key word aisa likha ho in front of the mirror? No. The size of the object by a mirror having a focal length 20 is observed to reduce its size. At what distance the object has been placed from the mirror, and what is the nature? And okay, so let's consider this one. Okay, so before considering this one, this is very important formula that we are going to drive here, because here it is being given that the focal length of the mirror is given 20. Focal length of the mirror is given 20. Okay, magnification is given 1/3. Why magnification is given 1/3? Because it is saying that the image is formed 1/3 of the size of the object. Okay, and nothing else is given to you. Okay, and what is being asked? It is being asked that where the object is placed. Here the image distance is also not given to you. So I have the formula. I have 1/f is equals to 1/v plus 1/u. Okay, and we have the formula m is equals to v by u. Got it? Got it? Minus v by
Sir,
u.
minus v by.
Now, if we consider, because here we need to ask the v, so we have to replace the value of v, okay, from this one by using so what is the value of v? We can write minus mu is equals to minus of v. Can I write like this way?
Yes, sir.
Can I write that v is equals to, I can bring this one from here. You can consider this one, that if it is written like this way, this u is going to multiply with this one, and you will get minus, then you will get minus v upon m2. Got it? Got it? Then
Yes,
v is
sir.
equals to minus m by u. Got it? So if I'm placing 1 by f is equals to 1 by v in place of v, can I add minus of mu
mu.
plus 1 by u. Okay, now taking the LCM as mu. So if I'm writing here mu, okay, and I'm just bringing this one, you can write 1 by minus mu upon 1 can be written as minus 1 upon mu. Got it? It can be written like this way. You understood?
Yes, sir.
So I can write here minus and plus, and here there is no m because I'm just taking the LCM. So can I write this as mu upon m? Now you cut it, you will again get 1 by u. Got it? So mu upon m, it can be written as like this way. So you can write 1 by f is equals to, take the LCM as mu, and that bring this side to this one and this to this one. So you can get m minus 1. Got it? Got it?
Yes, sir.
So this is the formula for, in terms of, if f is given to you, m is given to you, means the three things are here: f, m, and u. Okay, if two of them are given, then you can predict the third one. The formula is 1 by f is equals to 1 minus m minus 1. It was m minus 1. Yes, m minus 1. M minus 1 upon mu. Got it? Got it?
Yes, sir.
Yes.
And similarly for the image also, we can calculate the new formula for this one, for v. In terms of v, if we have 1 upon f is equals to 1 upon v plus 1 upon u, and here we have m is equals to minus v by u. So you can write it in terms of, if we need to replace u this time, because we don't have u. Okay, suppose we need to replace the u. In terms of v, we need to calculate. So u can be written as minus of v by m. We can write it. Can we write
Yes,
it
sir.
like this way?
Yes, sir.
Yes.
This goes to this side, this goes to this side. Now what is going to happen? You can write it like this way, that if this can be written as u upon 1, you can write it, u can be written as u upon 1. Now reciprocal this one, then reciprocal this one also. You can get 1 by u is equals to m by
Minus
v
v.
minus. You can write this way. Understood?
Yes.
Now right here, 1 upon f is equals to, write the value of 1 upon v, write it 1 upon v plus minus m upon v. Got it?
V.
Now take the v as LCM. You can write here 1 minus m is equals to 1 upon m. So this is the formula for v. So note it down, that if we have given m, v, and f only, no u, so you have to use this formula. If we have given f, m, and u, no v, then you have to use this formula. And if we have given f, v, and u, no m, so you have to use this formula. Got it? Got it? The three formula you have derived, okay, from the
Yes, sir.
formula. Now moving to this part, have everybody written? Have everybody written this one?
No, sir. Once again. Done, sir.
Done, everybody? Others? Amar and Hashit? Done? Now moving to the questions that we have given. Keep in mind all the sign convention you have to use. For example, for considering case 1, concave mirror. Case 1, assuming the mirror is concave. Assuming the mirror is concave. Okay, case 1. So for concave mirror, focal length is taken as negative. Concave mirror, for concave mirror, focal length is always taken as negative. Always taken as negative. Why negative? Tell me. Why? Because this is the concave mirror, for example. Okay, this is the concave mirror. So where you are going to measure, if the radius center, this is radius of curvature, and this is going to be focus. So this is coming on the left hand side, and this distance on the left hand side is measured in negative distance, because it is negative x-axis. Got it? And this is positive x-axis. Understood?
Yes,
Understood?
sir.
Yes.
So if it is given 20, so you have to write here minus of 20 centimeter. Okay? Got it?
Yes, sir.
Now, next one is given that it is 1/3 image is formed. So tell me 1/3 image is formed, that is a magnification is given to you. Now, do you think that if the image is diminished, can it be real or virtual? If we are considering case one that the mirror is concave, can it be real image 1/3 or virtual image?
Mm,
If
So
the
real.
image, yes, because it is m is less than 1, it means indicating diminished image, indicating diminished image. It is indicating diminished image, and diminished image can be only
Real.
real, because if it is forming virtual image, then the image is formed enlarged. Okay, so in that case, that cannot be. So it is given that. So if it is real, then we have to take is magnification as +1/3 or -1/3. -1/3. Okay, because real in case of real image we have to use, and keep in mind that we have to use proper sign convention. Okay, proper sign convention. So these two things are given to you, and what is being asked? The object distance. The object distance is being asked. You know that the object is arbitrarily chosen, that we have to place the object on the left hand side. To check whether your answer is coming in negative or not. Your answer must come in negative, with negative sign. Got my point? Your
Sir, I
answer
have a
Yes,
must
sir.
question.
come. Ask.
Sir, magnification is minus V by U, right?
Magnification is minus, yes, minus V by U.
Yeah. So like
But
if
here
you
it
if
is.
you ask, yeah.
But here the question is being given, that is also equals to height of image upon height of object. So if it is saying that the object, let's say image formed is 1/3 the size of the object. So if we consider that the image is, let's suppose object is of 3x, then the image will be 1/3 of this one, means that only x. When you cut it, you will get 1/3. Got it?
Okay.
Means if you consider that the object is of 3 centimeter, then the image will be 1/3 of this one. So 1/3 of 3 centimeter is 1 centimeter. You cut it, you will get 1/3. So it is indirectly given that the magnification is 1/3. Got it?
Yes.
Now moving to this part, now solving using the formula, that is 1/f is equals to 1/v minus, sorry, plus 1/u. Now it is being given that minus of 20, sorry, we don't have to use this formula. We have to use f is equals to, what was the formula? M minus 1 upon mu. Got it? So the formula that we have derived, in case if we have m, f, and u, only 3 things, and these 2 are given, this is unknown. We need to find out calculation. Okay, so we have to
Sir,
use this formula.
we should use the reciprocal, right? Because 1 by f is m minus 1 by mu.
Yeah. 1/f. It was 1/f now.
Yes, sir.
So you can use this one, this one, that is mu upon m minus. Got it? You can write it like this one, because reciprocal of this one will be equal to this one. Got it? Now put it, minus of 20 is equals to, what is the value of m? M is minus 1/3 into, what is the value of u? You need to calculate the value of u. Then again minus 1/3. Okay, and then minus 1. So magnification is taken as negative. Why? Because it is a real image. Focal length is taken as negative because it is a real, it is a concave mirror. Got it? Now solving
Yes,
this
sir.
one, you can find out that minus of 20 is equals to, you can take this, when multiplied with this, you will get minus u by 3. You can take minus u by 3 upon, when you take the LCM of this one, minus 1/3 minus 1, 3/3, you can consider this one. So this will add up and you will get minus 4/3. Got it? Got it?
Yes, sir.
Now, this 3 will get cancelled. And this minus sign and this minus sign will also get cancelled. You will get u by 4 is equals to minus of 20. Okay? U by 4. You will get u by 4 This 3 will get cancelled. Okay, this minus sign and this minus sign will also get cancelled, and this will goes to this side. Then you will get u is equals to minus of 80 centimeter. Got it? Got it?
Yes.
Yes,
So
sir.
this is the way that you need to calculate the formula by using this formula. Okay. Okay. Now, if considering that this is a virtual image, virtual image is formed by convex mirror. So
Convex
first
mirror.
first copy this one.
Done, sir.
Okay. Now moving to the next part. Let's assume the next part. Consider it as that it is a convex mirror. Okay, consider that it is a convex mirror. It is a convex mirror. For convex mirror, what you will consider? What changes will you take?
Focal length is positive.
Focal length will be considered as plus of 20 centimeter. And magnification, because it is a virtual image is formed, because convex
Plus.
mirror always form virtual image. So that will be taken as 1/3. Okay. The formula will be same. That is F is equals to mu upon m minus 1. So using this formula, calculate the value of u.
Sir, U is minus 40.
U is minus 40. Let's check. If we consider that it is plus of 20 is equals to 1/3 u upon 1/3 minus 1. So again here you will get plus of 20 is equals to u by 3 upon, when you take the LCM of this one, you will get 1 minus 3. Okay. Cut it, you can cut it, you will get minus of 2. Okay. So again you will get 20 is equals to
U by
equals
minus 2.
U by minus 2. This 2 will goes to that side and U is equals to minus of
Minus 40.
5. Very good. And to keep in mind here is that U should always come with a negative sign. If your U is not coming with the negative signs, it means that you have committed somewhere mistake. Okay. Got it? Copied, everybody understood?
Yes, sir.
Sure.
Yes.
Let's move further. Moving to the next point, let's move further. Let's have some questions regarding to this topic. Do question number 12. Do question number 12. Question 6 centimeter virtual elect. Concave. Question number 12. An object is placed at a distance of 10 centimeter of convex mirror of focal length 15. Find the position and the nature of the image. Okay. It is simple. Here the object is placed, object distance is given, that is 10. It is convex mirror, the focal length is 15. So done this one. Are we done?
Yes, sir. Once again.
Mark. Done?
No, so 1 second.
So it is being given the focal length is 10. The object distance is 10. Focal length is not 10. So it is 15. And object distance is 10. So will you take the object distance as positive 10 or negative 10?
Negative 10.
And that of focal length?
Positive 15
Positive. Why?
plus
Because
15.
because it is convex mirror. Okay?
Convex mirror.
Now what you need to calculate is 1 by f. Sometimes the student used to do some mistake here by interchanging. What do you need to do? What do you need to calculate? B. First you drag this formula. 1 upon f minus 1 upon u is equals to 1 by b. Now using this formula, 1 upon f is 10, so write 10, sorry 15 minus. This is the minus sign of the formula, but you have to put with your own minus sign. You can also consider it like this way. Okay, you can write like this way. Because 1 upon minus 10 is also equals to minus 1 by 10. Then write 1 by 15 is equals to, sorry, 1 by 15 minus minus get plus, this will be plus 1 by 10 equals to 1 by b. 1 by b equals to take the LCM. You can take the LCM as 30, 2 plus 3. Okay, plus 3 to 5. We get 5 by 30 equals to 1 by b, cut it, we get 1 by 6.
V is 6.
6. V is 6, positive 6. What does it mean? what does this mean? You can also imagine the condition that it is forming a virtual wave. Why? Because the focal length is 15. Focal length is 15. This is 15. And sorry, this was convex mirror. This was convex mirror. So that it will always going to form the virtual image. So no need. So V positive is coming, it means the virtual image is coming. Okay, got it?
Yes, sir.
Do question number. Question number 11.
Sir, it's lens, concave lens.
Question number 11. Oh, it's nice. So do question number 15. Do question number 15. Go fast.
Sir, V is minus 54.
V is minus 54. Okay. Others? Other student? Here V is also minus 54. Mark, done?
No, sir. Also.
So what is being given to you? An object is placed at a distance of 10 centimeter from a convex mirror. So again, object is placed means U, it means minus of 10 centimeter. You understood it? And since the focal length you need to calculate. Sorry, it is given. Focal length is 15. So 15 centimeter means plus 15 because it is convex mirror. So take plus 15.
Sir, we already did this question.
So which was question we were doing? Oh, we are doing question number 14 now. Yes, yes. An object of side 14 centimeter
So it was
centimeter
15.
is We are doing which one?
15th one, sir.
15th one we are doing, na? Okay, let it be. So it is being given then object of size 7 centimeter is placed at a distance of object size is 7 centimeter placed 20 centimeter in front of a concave mirror of focal length X. So it is being given to you that the focal length is, what is the focal length? Tell me.
Minus 18.
Minus 18. Okay. Object distance?
Minus 27.
Minus 27. Height of the object?
7 centimeter.
Plus 7 or minus 7?
Plus 7.
Plus 7. Because it is taken as if the distance, the upside the distance is measured with plus y-axis. So what we need to calculate? We need to calculate the v. So you can easily calculate the value of v by using this formula, that is 1 by f is equals to 1 by v plus 1 by u. So what will the value of v again? 1 by f minus 1
Minus
by
1 by u.
is equals to 1 by v. Put that value. Before the LCM, so if you are multiply by 3, but this minus sign get plus. Okay, again this is minus sign and minus sign get plus. You will get 3 upon 54. Okay, minus 3 by 3 plus 2 upon 54. So you will get 54 3 minus 2 equals to 1 by v. So you will get minus 1 by 54 equals to 1 by v, and v is equals to minus 1 by 54. Can you tell me that where the object is placed? In this condition, can you tell me where the object is placed? Between f, beyond f, between r and f, where it is placed? Tell me.
Between R and F.
Yes, because 2f will be at minus of 36, but here it is in u is at minus 27, means this is f, that is of minus 18, and that is at 2f, that is of minus 36. So here it is placed between r. So the image will be from beyond, and it is
Beyond
enlarged. Enlarged. It will be
Real
enlarged, like
and
inverted.
inverted.
And since the height of the object is given to you, so what will be the size of the object? You need to calculate image size. So you can use this formula, m is equals to minus v by u is also equals to height of image upon height of object. So by using minus v by u is equals to height of image upon height of object, you can calculate this. Minus v, what is v?
Minus 54.
Minus 54.
54.
This is the minus sign of formula, so you have to write here minus 54 because it has come with sign. Against u, what is u? Minus of 27. Again, you have to put with minus sign. Okay, v and u should be placed according to their sign if they are given. Height of the image you have to calculate. Height of the object is given plus 7. So you have to write here plus 7. This will get, you will get minus 2. Okay, minus 2 is equals to height of image upon 7, then it should be h is equals to height of image equals to minus of 14. Minus of 14 indicating that the image will be from double of size of the object, and it will be real quantity because minus this distance is measured in minus with negatives, in negative axis. Got it? Understood?
Yes, sir.
Moving to the next portion, let's start with the refraction topic. Okay, refraction. So wait a minute. Let me remember something. To start with refraction. What do you mean by refraction? The topic, the numerical problem, I'm going to give you some practice question regarding to this one in the homework. So please practice them in the homework. If you are having any doubt regarding to these questions, numerical problem, then I'll go into discuss. Okay. So let's discuss the refraction now. Refraction, what is refraction? Refraction means that when a light passes from one medium to another medium, it bends. And this bending phenomena of light is known as refraction. You understood? This bending phenomena, when the light passes from one medium to another medium, so the light get bends. The light get bent in that medium. Okay, the light get bent, and this bending phenomena is known as refraction. Bending of light when it passes from one medium to another medium is called refraction. Okay, and one thing you need to keep in mind here, that the speed of the light, what is happening that when the light is moving from one medium to another medium, so you see that if the speed of the light decreases, yes, the speed of the light decreases. When because you know that the speed of the light is maximum in vacuum. Speed of light is maximum in vacuum. Okay, and minimum in solids. Minimum in solid. Okay. So when a light is passing, suppose a light is passing from one medium to another medium. So for example, this is vacuum, sorry, or air, you can consider the light is moving. But when it entered into the glass, its speed decreases. Speed decreases. And as a result of it, because of decrease in the speed, the light get bent. The light get bent. Okay, the light get bent. Okay. So why it is bending? Just because of the speed of the light is decreasing. Okay. Now we know that speed is equals to frequency into wavelength. Yes, it bends due to speed of the light decreases. Okay. But if you see that, if I'm saying that the speed of the light is equal, let's suppose the initial speed was, let's suppose it is 3 lakh kilometer per second or something. Let's imagine, I'm not going to give you a big numerical value. Just imagine there is a number, whose product, there are two numbers whose product is 10. So it can be 2 and 5. Okay, it can be 10 into 1. It can be 5 into 2. Okay, got it? You understood what I want to say? The product,
Yes,
if the
sir.
product of two number is 10, then it can be 2 into 5. For example, let's suppose now the product has become 20. Now the product has become 20. Okay. And if the product has become 20, then what is going to happen? Let if I'm saying 5, the initial product was 10, and it is 5 into 2. But if I'm saying that this number remain constant, it is not going to change. Then in order to bring this 20 as a product, you need to increase this number. You have to increase this number. If I'm saying that 5 is going to constant, it is not going to change. So you have to increase this number in order to bring this 20. Understood?
Yes, sir.
Okay. For example, if I'm saying that there are two numbers, for example, let me explain you here by using this speed. Speed is equals to frequency into wavelength. If I'm saying that suppose frequency remain constant when it does not, and light passes from one medium to another medium. So what is going to change? Its wavelength is going to change.
Wavelength.
Or suppose if I'm saying that if wavelength remain constant, then frequency is going to change. Because if we need to decrease this value, one of them, if I'm keeping one constant, then other must decrease. For example, here also, if I'm saying that 10 is equals to 5 into 2, and if I bring the product as 5, if I'm saying that 5 should remain constant here, the first number remain constant, then I have to bring this number, convert this number to 1. Got it? So if one number is constant, then we have to bring, because the product has decreased. So if this is constant, then you have to decrease this. Similarly, if I am saying that frequency is constant, then wavelength must decrease. If wavelength is constant, then frequency must decrease. Got it? So what is going to happen here is that when the speed of the light The speed of the light changes when it passes from one medium to another medium, and the frequency remains same. The frequency when the light travels from one medium to the other remains same. Okay, this time so many times this question comes in examination that the thing that does not change when the light travels from one medium to another medium. So what does it change? Its wavelength changes. Wavelength changes when it passes from one medium to another. Note it down. Note it down, dear students, please. Value that is that we do. Okay.
Done, sir.
So 1 second, I was still doing one.
Okay. Okay.
So
Sir,
last.
sir, can I
Yes.
leave the meeting? I have to leave for the airport right now.
Okay. Where are you going?
Sir, India.
You are coming to India.
Yeah, yes, sir.
Oh, come on. Okay. Come.
Okay, thank you,
Where?
sir.
Okay.
Bihar, sir.
Yeah. Okay.
Done, sir.
Yeah. Okay. So moving to this point, we have the two types of medium that we're going to study. Okay, one is the rarer medium, another one is the denser medium. We need to discuss this one. That there are the two types of medium that we discuss. That is, one is the optically rarer medium, another one is the optically. There was optically rarer and optically denser. So, for example, if the ray of light is passing from one medium to another medium, and if it bends towards the normal, what is normal? Normal is any line that is perpendicular to the surface of contact. For example, ray is entering to this way. A ray is entering from this way. So there will be considered as normal. If the ray is entering to this way, so this will be considered as normal. So normal is any line that is passing to the perpendicular to the surface of contact. Okay, this is the normal line. This is normal. We can represent it normal line. Normal line. Okay, so if an incident ray is passing through it, let's suppose if an incident ray is passing through it, an angle of some incidence, and if it bends towards the normal, let's say it is going to actually it is going to this way, but it bends towards the normal. Bends towards the normal. Okay.
And it's
Yeah, right.
optically rare.
Okay. So then this medium will be considered as compared. This is medium 1. This medium is 2. This medium, if we consider the medium 1 and 2, then we can consider that medium 2 is denser than as compared to medium 1. Got it? In case if the ray is moving from denser, you can see that if this is a glass slab, okay, and if the ray is coming from this glass slab, and if it bends away from the normal, now again I'm drawing the normal here. So the normal, and if it is actually going to this way, it is actually need to go to this way. But if it bends away from the normal, okay, then this is the medium 2 and this is medium 3. We can consider that medium 2 is denser or medium 3 is rarer as compared to medium. Got it? Got it? Understood?
Yes,
And when the light ray pass from rarer to denser, the speed decreases. And when it passes from denser to rarer, speed decreases. Done? Sorry, speed increases. Speed increases. Got it? Please note it down. Yeah, you can leave us. That's all. We'll discuss this one in the next class. Okay. That's all for today. And everybody.
yes.